Hi, welcome to the Spectrum Protect version 8.1.2 demo. In this demo, I'm going to be showing you how TLS 1.2 is now the default for communications between the Spectrum Protect server, admins, Operations Center, clients, and storage agents. Previously, SSL was optional, and the certificates had to be manually installed, and the server had to be restarted in order to start utilizing those servers. But with 8.1.2, we now try to automatically exchange those certificates, and this simplifies the configuration and really does assist in the automatic use of SSL TLS 1.2 for the communication portion. This is not the data portion that's being utilized with SSL TLS 1.2, just the communication portion of it. With this, we can utilize the self-signed or the CA-signed certificates, and we try to automatically ensure that all the required certificates are exchanged. And this happens at the session start. Basically, the server will check for a copy of the certificate in the server's database, and then the certificates are communicated via server-to-server SSL and a protected password. Then the certificates will be placed in the trust store with an identifiable label. And for the server, that trust store is the cert.kdb. For the admin and client, that's the DSM cert.kdb. And for the operations store, that's the GUI trust store.jkm. This works for all server-to-server sessions. If you're doing a defined server, you do need to make sure cross-define is set to yes to allow this bi-directional exchange of the certificates. Currently, though, for the storage agent, you do need to manually configure that. The certificate exchange is just for version 7.1.8 and above, as well as 8.1.2 and above, and you must be utilizing the new V2 authentication. And part of that V2 authentication also checks on this new session security parameter, and I'll be showing you this in the demo. And this session security is going to either be set as strict or as transitional, and it basically determines whether that entity, whether it's an administrator, a node, or a server, must use the most secure settings to communicate with the Spectrum Protect server. And currently the most secure settings would be TLS 1.2. Maybe in the future it'll be TLS 1.3 or whatever else comes down the road. Strict means that we're enforcing the utilization of TLS 1.2 between the two entities, versus transitional, which means TLS 1.2 is not being enforced. And so you might see this, for instance, with down-level administrator or nodes or down-level servers. We do have a tech note out there, and you can read that if you want additional information on that. The exchange of the certificates should occur automatically underneath the covers. What I'm going to be showing you in this demo is what is happening underneath the covers. I'll be using the command line, and I'll be showing you all the details, just in case you want to know what's going on, or in case you do want to manually exchange the certificates. And what I plan on showing in this demo is where we have the primary server and the target server exchanging certificates automatically, and those certificates being placed into the primary hub server's trust store, as well as the target or spoke server's trust store. I'll also show how an administrator can connect in and what gets placed in the administrator's DSM cert.kdb trust store. For the Operations Center, I did a separate video on that, and that separate video shows how the Operations Center works with the hub and spoke server, so check that video out. Okay, so let's go ahead and get started. We're going to start by looking at the cert.kdb, which is installed when the Spectrum Protect server is started, and at the self-signed SHA key, which is inserted there. This will be important because once we start doing server-to-server, you will see other Spectrum Protect servers certificates showing up in the cert.kdb, and we utilize the GSK8 CAP-I CMD _ 64-cert-list-db cert.kdb-stashed. And the cert.kdb is the default name of the Spectrum Protect server trust store, and the -stash just means the password has been saved. So let's go ahead and start up the Spectrum Protect server, and when we start it up, you will see that the Spectrum Protect default label in the key database is TSM server self-signed SHA key. Now we're going to switch over to the second Spectrum Protect server. This is what we're going to call our target server because when we do replication, we will replicate over to this server. We're also going to take a look at the cert.kdb over here using the same gsk8 command, and you will see it too has its own self-signed SHA key showing up in the trust store. Let's go ahead and start that second server up. And now we're going to switch back to the primary server and take a look at the state of the TLS 1.2 inside of the primary server at its initial startup. We're going to issue a query admin, the admin name format equals detail, and this will show us the new property session security. And session security will either be strict or transitional. Transitional specifies that the existing security settings are enforced by the server or client, and that it can still try to automatically exchange these TLS 1.2 certificates on the first communication. Strict means that the settings are being enforced, and to establish a session, the server or the client must use TLS 1.2. So you can see here that our session security is transitional, and because we haven't authenticated with this server, the transport method is still a question mark. Next, we're going to issue a query server, and this will show any of the other servers that the primary server knows about. And when we issue this, you'll see we currently are not in communication with any of the other Spectrum Protect servers. We will now issue against the target server the same query admin name format equals detailed. And once again, you'll see that the session security is set to transitional and the transport method is set to a question mark. And likewise, if we issue a query server, the target server does not know about any other Spectrum Protect servers. So let's go ahead and start the server-to-server definitions. On the primary server, we need to set its own server password, its own server high-level address, its own server low-level address, and we must set cross-define to on so that when we do define the target server to it, they will automatically exchange certificates. On the target server, we'll do the same definitions to define the target server's server password, high-level address, low-level address, and once again, also make sure we do the set cross-define on so that it will automatically exchange certificates with the primary server. Now on the primary server, we're going to define the target server utilizing the defined server, the target server name, the target server password, the high-level address for the target server, the low-level address for the target server, and cross-define equals yes. And this will cause the certificates to be exchanged between the primary and target server. If you're using the Operations Center wizard, or if you've already done this on your server and all you did was upgrade to version 8.1.2, when node replication kicks off, then the certificates will be exchanged underneath the covers on that first attempt for node replication. We can see the defined server was successful. Now there is an error that occurred here. If you do see that, you'll want to take a look at the tech doc that we have available, and it'll show you how to resolve that. Now on the primary server, if we issue a query server, you will see that we see the target server. So if we take a look at the trust server for the primary server, utilizing that gsk8 command, you'll now see not only the primary server's self-signed SHA key, but also the target server's certificate shows up. Let's now switch over to the target server and issue the same command. And here you will see the primary server's certificate as well as the target server's default certificate. So this shows us that the TLS 1.2 certificates were automatically exchanged. When we issue a query admin ID format equals detailed from the primary server, you'll still see that it's in transitional state. That's because the defined server does not invoke and change the session security settings. Now let's go take a look at a Spectrum Protect admin client and how its certificates are managed. In the client directory, you'll see dsmcert.kdb, and if you take a look inside of it with the gsk8 command, you'll see the two Spectrum Protect administrator certificates. Now if we try and connect to a Spectrum Protect server using the dsm-admc command, once we log into the Spectrum Protect server, let's issue the query admin, the same admin ID that you logged on with, format equals detailed, and you'll now see that the session security has been set to strict and the transport method has been changed to SSL TLS 1.2. And that's because this administrator now has logged on, made connection with the server, exchanged certificates. If you go and look in the certificate database again for that administrator, you'll see we now have the server certificate for that primary server we just logged on to. In the admin trust store, the server certificates will show up as an IP address versus what we saw in the server trust stores where the other servers showed up with a name for their certificate. Now if we want to manually add in a certificate here for the target server, the first thing we have to do is go out to the target server and obtain the certificate, the cert256.arm certificate that's automatically created for each of the Spectrum Protect servers. We're going to go ahead and get that certificate from the target server, but we're going to give it a new name so that when we bring it back to the admin client, we don't get it confused with any other certificates. So in this case, we're going to call the target server cert256.arm certificate cert256array.arm. Okay, and you can see that certificate is now on the administrative client. And now in order to add it into the trust store, we're going to issue the gsk8 capi cmd_64-cert-add-db, the name of the DB, which is dsmcert.kdb, --label. You can give it whatever label you want. And then -format space ASCII -trust enable -file, and then we'll give it the name of the file that we just brought over from the target server. And once we've issued that command, then we'll want to list out and make sure it's actually in there with the list command. And here you can now see that not only do we have the administrator certificates, the primary server certificate, but also the new target server certificate that we just manually added in. So now anytime that this admin tries to connect to the Spectrum Protect server, it will need to use the TLS 1.2 protocol because the session security is now set to strict. So I'm going to register a new administrator called Trisha. So register admin Trisha, we'll give it the same password. Now I'll go ahead and query that admin to show that it is still in the transitional state and that the transport method is set to question mark. If we now quit out of the admin and then log in this time as Trisha, we're going to log into the server. And once we're on again, this time we're going to query admin Trisha, format equals detailed. And we should see now that the session security has changed from transitional to strict, and the transport method is SSL TLS 1.2. So let's quit out of here and issue the gsk8 capi cmd to see what's changed in the trust store. And you'll see that no new certificates were set in here because once we've set the certificate for that particular server, it doesn't matter which admin or client logged in from that machine. However, if you use this administrator who now has session security strict from a down level Spectrum Protect administrator, you will find that it will be rejected. So let's try logging on from a down level ad machine using the ID equals Trisha and connecting into the same server. You'll see immediately when we issue that command, we get this error, session rejected, down level client code version, unable to establish session with server. And as you can see, that was a version 7 client, and we were trying to connect into a version 8.1.2 server where the admin ID had the session security set to strict. To get around this, you would need to register another admin that was dedicated to just being used with the down level clients. So So here we're going to register admin Trisha1, issuing a query admin Trisha_1, format equals detailed. You'll see that this new admin's session security is set to transitional. So we can now use this with the down-level Spectrum Protect admin client code. So now we can log in from the down-level client code, and when we issue the query admin Trisha_1, format equals detailed, you'll see that the session security is still at transitional, but the transport method has been set to none because we are not using SSL TLS 1.2 for this specific admin ID. So in conclusion, Spectrum Protect 8.1.2 introduces TLS 1.2 for the communication between server to server, administrator to server, client to server. So when you log on for the first time to your 8.1.2 servers, they will try the first time to automatically exchange their Cert 256.ARM certificates and place those in each other's trust stores. If this does not happen for some reason, you can manually insert them. Same with an administrator. When it logs on to a new Spectrum Protect 8.1.2 server for the first time, it will obtain that server's TLS 8.1.2 certificate and put it into a dsmcert.kdb. A new property has been added to the different entities called session security. And once that goes from transitional to strict, then you can only use that entity with the 8.1.2. So for instance, if you had a Spectrum Protect admin that's logged on to an 8.1.2 server, you will no longer be able to use that same admin name to log on from a down-level admin client. Thank you for your time.